Good day, everyone. So today I'll be doing the last section under organic reactions, which is substitution. And hopefully these notes will be useful in the near future when you need them, right? So let's get to it. So under this reaction, I want you to think of taking a saturated compound and substituting something from that and still form a saturated compound, right? So it's from saturated to saturated, and the chunking method that we use here is SSS. Saturated compound to saturated compound, that's substitution, right? So we start with hydrolysis of dilute base. So here we're taking a haloalkane, we're adding our dilute strong base to form alcohol plus salt. Then the conditions for this one, use low temperature. Then we have to also use a dilute strong base. And lastly, the solution must be in aqueous. So here we have a haloalkane. Then we add our dilute strong base. To form alcohol. So here we're not reducing any number of H atoms or the number of molecules that you have, but we're just replacing, right? So in our case, we're going to take Cl and bond it with Na. Then in place of Cl, we're going to take OH and place it there. So it's going to be 1, 2, OH, then our salt, NaCl. We still have the same number of, you can see that the number of molecules remained unchanged, or it's still a saturated compound and we form salt and alcohol. Let's take another example. Let's say we have 1, 2, 3, Cl, H, 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 H. Then we add our KOH. Same application. We take our Cl and replace OH. Then we take the OH and replace our Cl. Then we're going to form salt. And an alcohol. Right? Number 2 is going to be hydrolysis of what? The conditions are still the same. The only difference is that we don't use dilute strong base. We use the solution, the section where we talk about the solution must be an aqueous. The only difference between this one and the first one is that we're not using a dilute strong base, we're using water. Let's take an example. So we'll take our haloalkane, add our water to form our alcohol. So in place of Cl, we'll put OH, and in place of OH, we'll replace it with Cl. So we're going to form and HCl. Okay. The third one that we're going to do is halogenation of alkane. We take alkane, add H2 to form a haloalkane. Then the conditions for this one is going to be heat or UV light. Let's take this example. So what's going to happen here? We're going to replace an H from our alkane with Cl, and our Cl is going to be replaced by H. So here we're going to form a haloalkane. 1, 2, Cl, to form HCl. And the fourth one is halogenation of alcohol. And the best one to use is a tertiary alcohol. Then higher temperature is required for secondary and primary alcohol, which will make the reaction much slower in our case. So let's take an example and see how it works. Let me just for reminder, we know that it's a tertiary alcohol because the C atom bonded to OH is between 3 other C atoms, right? So in our case, we're still applying the same thing. The OH will be replaced by Cl and all that. And the Cl will replace the OH. So we're going to form CH3, 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 Cl to form H2O. So you can see that it's still a saturated compound and we formed water. So that's all under substitution. And let's do a recap. The first step that we did is hydrolysis of dilute strong base. We take a haloalkane, we add a dilute strong base to form alcohol and salt, and these are the conditions. And the second one is hydrolysis of water. They have the same conditions, but the difference is that we're not using a dilute strong base, but we're using water. The third one, we did halogenation of alkane. As you can see that the condition we need heat. And the last one, we did halogenation of alcohol under substitution. And the best alcohol to use is a tertiary alcohol because the others will require a higher temperature and it will make the reaction slower and all that. And that, okay, and that's it for today. Bye.